We're now into the double angle sine 2x. I asked you before the break to write down your formula. So let's see whether you've got it. So sine 2a can only be broken up in one way. Sine 2a can only be broken up in one way. 2 sine a cos a. Cannot be broken up in any other way. So sine 2x would be 2 sine x cos x. So sine 2a would be 2 sine a cos a. You take the angle, you take the 2 in the front, so 2 sine x cos x. You take the 2 to the front, 2 sine a cos a, 2 sine x cos x. We now go into cos 2x. How many ways can the cos 2x formula or the double angle for cos be broken up? Yes, you are right, grade 12s. In 3 ways. So the sine can only be broken up in one way, 2 sine a cos a, but cos 2a can be broken up in 3 ways. What are the 3 ways in which it can be broken up? Number 1, it can be broken up into cos squared a or cos squared x minus sine squared x, right? Or sine squared a. Right. Number 2, right? Now remember, if it was in grade 11, you know that sine squared plus cos squared as an identity is 1. But cos squared minus sine squared is cos 2a. Then you have 2 cos squared a minus 1, or the last one, 1 minus 2 sine squared a. So if you want to break this only in terms of cos, that's the formula you'd use. If you want to break this formula up, the cos formula, in terms of sine, that's the formula that you would use. So there are your formula. Compound angle, there's the 2 formula. Sine a plus b, sine cos, cos sine, the sine stays the same. Cos of a compound angle, cos cos, sine sine, the sign changes. Sine 2a can only be broken up in how many ways? One way. 2 sine a cos a, but cos 2a can be broken up in how many ways? 3 ways. Cos squared a minus sine squared a, 2 cos squared a minus 1, or 1 minus 2 sine squared a. Okay, guys, I hope you screenshotted this. You took your phone and you screened it, or you paused. If you've got PVR, you pause the screen. These are your formula. I hope you've taken them down. Let's now go into application. Okay, so we now go into the application of this. We're going to start with compound and double angle identities, and we're going to be using these 2 formula in order to prove our identities, to do our reduction, or remember, compound and double angles will be in all the topics. So whether it's in an equation, or whether it's in reduction, or whether it's in trigonometry on different planes, these will be integrated in all your topics. Okay, so let's start with question number 1. They say, prove each of the following identities. And these are all exam style questions. So let's start exam type question number 1. And the question says, prove. And we say, root 3 sine x plus 60 degrees. I want you to take this down as I'm taking it down. Minus sine x plus 30 degrees is equal to cos x. Now it's worth 6 marks in the exam. The question, that's your question, it's saying prove. So basically, what do we need to do? We need to prove that the left-hand side of the equal to sign, that the left-hand side is equal to the right-hand side. Obviously, we know on which side do we start. We start on the more complex side. And which is the more complex side? The right or the left? The left, obvious. So let's start here, left-hand side. So we say left-hand side. Now, we're only dealing with this. We're not dealing with the cos x. So what do we have? I've got root 3 in brackets. I'm going to expand this. Watch. That's the round brackets. That's the square brackets. Minus. And now I'm going to expand this entire component into another set of brackets. So we've got 2 brackets here because we have 2 components. We've got a component A and we've got a component B. Component A, component B. Remember, structure being very important.